Hi everyone. In this video, we are going to see how to create the multiple threads by using single object. This example already we discussed in the previous video by creating two threads for two different classes. You see here object 1 is belonging to the class VIT, object 2 is belonging to class AP, and object 2 is working for thread 2, object 1 is working for thread 1. So two different threads are using two different class objects. Okay, but the single object can be used for multiple threads like T1, T2, T3, etc. And also obj2, that single object can be used for thread 1, thread 2, thread 3, etc. So this kind of example we are going to see now by creating multiple threads to work on single object by using thread constructor with runnable interface. So the block diagram is showing that user defined class is implementing the runnable interface. As per that, I am writing the code here. Then as per the procedure, every class which is implementing runnable interface should have the run method that is defined here, which is performing the action for 3 iterations. Just it is displaying the currently accessing or running thread name for each iteration which is introducing 1000 milliseconds delay. As per this, the run block is created in the diagram. Then I am going to define thread ex7 is the driver class name to create the object obj. So as per that, code is written here. Thread ex7 main method is written because this is the driver class. Then obj is created by using the class name is vit. Then now I am defining the thread t1 for carrying the obj object. So as per that, thread t1 is defined by using the constructor thread class. Then obj is carried out by this t1. Then I am assigning the name for this t1 is learn. Like that, second thread t2 is created to carry out the object obj. Here the name is assigned for this interpret. Then thread t3 is created to carry out the obj variable and name is assigned as knowledge. Now multiple threads, 3 threads are accessing the single variable obj, right? So now we are going to invoke the start method for all these 3 threads. T1 is starting, right? Once it is called the run method automatically, which is overriding the runnable interface method run by using the user defined method run. Okay, so the user defined method run is overriding the interface runnable interface method run, which is abstract method. Built-in method will be available. This method, okay, is available inside the run method runnable interface. This is overridden by this user defined method. Just it is displaying the currently running thread name, right? Then which is introducing the delay 1000 milliseconds. Okay, now for second thread we are invoking the start method. I am invoking, then this also invoking the run method, right? And also displaying the currently running thread name, that is interpret, and also it is introducing the delay 1000 milliseconds for each and every iteration. Like that, T3 is also invoking start method, right? This also will run for 3 times, but it is introducing 1000 milliseconds for each iteration delay. So based upon that, you see here initially the T1 is started, T1 started, and this indicating the thread priority and name is main thread, right? So now thread 2 is initiating that. So before thread 2 comes, within this 1000 milliseconds delay, thread 2 is getting the CPU for execution. You look at that. Okay, you see, right? Thread 3 is the knowledge. Okay, right? Thread 2 is interpret. Before interpret coming into the CPU for execution, the knowledge got the CPU for execution. Okay, then 1000 milliseconds introducing as a delay, then only second thread is getting the CPU, right? But here you see for second iteration learn got right? For second iteration, before interpret comes, knowledge came, right, again. So you look at that here, the single object obj is accessible by multiple threads parallelly. Okay, t1 also accessing, t2 also accessing, t3 also accessing, but right, by introducing the delay here 1000 milliseconds. So why I am introducing the 1000 milliseconds in the sense, then only we can identify the execution allotment of the CPU for each and every thread, right? Otherwise we cannot identify that. If you are not giving 1000 milliseconds at a stretch, all the threads will display, so we cannot get that. So I will show you the output here in the command prompt. So in this command prompt, I'm running the program, right? Program name is thread ex7. You see, first interpret coming. You look at that. In this one, interpret coming first, and knowledge coming second. Actually, interpret is the thread 3. Knowledge is thread 2. Learn is thread 1. You see, before starting of the thread 1, thread 3 got the CPU. Then thread 2 got the CPU, right? So based upon that, here we are allotting the CPU, right, based upon whichever thread coming first or coming second, right? Once it is idle, it will allot to any thread. I am compiling for next time, running for second time. You see, now learn comes first. You see, in this two execution times, right? So the threads are allotted to the CPU, right, in different manner. If I'm running for third time, you look at that, knowledge comes first. Okay, so the CPU will be allocated to each and every threads in different manner if CPU is idle. From this example, we may observe that CPU is allocated to the threads based upon the idle time. So the thread scheduler will allocate the CPU for all the threads which are available in the queue. So we have seen different kind of thread creation here, right, by using the inheritance of thread class or implementing the runnable interface. Which one is recommended? When user is extending the thread class to create the thread, user cannot extend another one class even though it is needed for his requirement. So when user is implementing the runnable interface, he can extend another class. For example, you see, when class vit is implementing runnable interface, suppose the developer wants to extend one more class, that then he can use the code like this. Here he is using the interface and also he is using the class parent class. But when he is using class A extends another class, suppose B, then if he wants to another class C, he cannot use it here. So that is the issue when you are using the extends based method to create the object. So here the user is recommended the runnable interface than using the thread class to create the object. So for example, you see, when user is using the runnable interface, he can use the object, single object, to use multiple threads. You look at that, this obj1 is using for multiple threads, but when you are using the thread class, you cannot use like this. Okay, you have to use only single thread for single class. So that is also one of the limitation when you are using the extension of this thread class. So the recommendation is here to use runnable interface whenever we are going for multi-threading approach for using single object for multiple threads. Thanks for watching.